Hi everyone. To start off your intro to robotics project, you're going to be working on some CAD. CAD stands for Computer Aided Design, and basically it's a software package that allows you to design your robot completely on the computer before you go building it in real life. This helps you to rapidly experiment on proper design, proper dimensions, without having to build it all in metal or wood or whatever first, so you can do it much more quickly. It also saves a lot of resources for the team. The particular CAD package that we use is called SolidWorks, and I have it open here on the screen. Let's go ahead and get started. So this is what we'll be designing. It's a basic robot to play the Sumo robot game, so whoever can push the other one out of the ring first wins. You can see it's pretty simple. It has a couple of wheels on the back here, a plow up front for pushing the other robot around with. It's got a battery pack here in the middle, and up on top got our Raspberry Pi board with a motor controller on it and some sensing on it so that we can figure out where the other robot is. And then right here is also going to be a sensor for detecting the edge of the arena so that we can make sure that the robot doesn't drive too far and drive itself out of the arena, which would be bad, of course. So to get started designing your own, you can go to tinyurl.com/sumokit, and that will get you this set of files that you can go ahead and download. Once it's finished downloading, you go ahead and extract the set of files that are in the zip file there. And this gives you a set of starter models that you can start building up your robot model with, though it doesn't include everything. Let's go ahead and take a look at what's in there right now. So it includes a number of kind of basic parts. You can open a couple here and take a look. For instance, this is a wheel hub for attaching wheel to our motor. This is a ball caster, so this will be used as kind of the third wheel on a robot to help keep it up, in addition to the two drive wheels. And a metal standoff, which will be part of our structure. And we also have some larger assemblies, like this one, for instance, is a motor with some of the attachment hardware, the wheel on the output here, and here's that hub in the middle that we saw just a second ago. So you'll be working on two parts of this. You'll be working on the base plate, which is the bottommost part of the robot that everything attaches to. You'll be designing that from scratch, and then you'll be assembling that into into a full robot assembly with all the rest of these parts. We'll start first with making the part for the base plate. So to do that, go up here and click the New File button in the toolbar. Make sure Part is selected, and then hit OK. And now we have a new blank part open. The way that CAD software usually works is that you first design a part in 2 dimensions, and then you bring that 2D sketch, as it's called, into the 3rd dimension. We start out with 3 reference planes, the front plane, top plane, and the right plane, that split our model into parts. We can choose any of these to start designing the 2-dimensional part of our part. Let's pick the top plane for this. So when I click on it over here in the browser on the left-hand side, it brings up a set of icons that I can choose from. The first one here is Sketch. If you click on that, it will bring us into sketch mode. We are now in the 2-dimensional part of CAD. You see it's changed over to the Sketch tab of the toolbar up here. And we have a set of tools that we can use to start making our drawing with. The first thing that we're going to put out here is a center rectangle. The default rectangle is a corner rectangle, so it's specified by the two corners, but we want to use a center rectangle. So click the arrow next to the rectangle, and then click center rectangle. The first point that we select is the center, and we will select the origin point, which SOLIDWORKS has put out there for us. You can see that when I mouse over it, a little dot appears. That lets me know that I'm actually clicking on the center. So click once there, and then as I move my mouse around, it's now going to show me the rectangle that I would create if I were to click again. The specific dimensions initially don't matter because we will be actually giving it some exact dimensions once we place the rectangle. So click once again anywhere out here to finish making a rectangle. And then we're done making this rectangle, so we want to get out of rectangle creation mode. So you can either press the icon on the toolbar again or press escape key, which is usually much faster. Now we're going to make a second rectangle. This one will be a corner rectangle. So select that again from the drop down next to rectangle. This one we'll place slightly above the other one by selecting 2 points for the corners. We now have some basic shapes out here, and it's time to give these dimensions so that we know exactly how big they will be in real life. As you move on into designing your own parts, part of the design process will be figuring out exactly what those dimensions are. But for starting out, I'm going to go ahead and give you the dimensions. If you click the Smart Dimension button on the toolbar, it brings us into the mode where we can start adding dimensions. I'm going to click once on the left side of our first rectangle, which starts the creation of a dimension there. Drag it out a little bit and then click again to place the dimension. It's now asking us for what value we want to assign the dimension. This one will be 3 1/4, so 3.25, and you can press enter. By default, the units are in inches because that's the primary measurement system that we use on 766. But there are options to change the metric if you so prefer, but generally the rest of the team will be using inches and feet and so forth, so I'd recommend you leave it there. The other dimension we can create by clicking the bottom of the rectangle once, dragging out, clicking again to place the dimension. This one is going to be 4 1/2 inches, so enter 4.5 and hit enter. As you can see, this rectangle's border has now turned black, which lets us know that that rectangle is fully dimensioned. So we can't move it now because the set of dimensions that we put in there exactly specify how large the rectangle is and where it's placed. We'll now move on to the second rectangle. This one will be 1 3/4 inches, 1.75. By 5 7/8, 5.875 inches. As you can see, even though I specified 2 dimensions here, it's still blue because the position of the rectangle is not locked down. Well, I can't change its size anymore, I can move it around, so I'll have to specify more dimensions. By this point, you may have gotten yourself a little bit off to the side of your drawings, so it's a good opportunity to explain how to move around in CAD. If you're using a mouse, the primary interface will be the mouse wheel on the mouse itself. If you scroll in and out, it will zoom in and out of your drawing. And if you press the mouse button, or mouse wheel, if you click it down and then drag, it will rotate. If you hold down the control key while you click the mouse wheel and drag, it will pan side to side. So you can use that for easily navigating around your drawing. So to finish locking down our second rectangle here, what we'll do is right click on the bottom line and come down, I didn't get quite on it, click there, and you'll see an option called select midpoint. If I click that, you'll see it's put up a little dot in the center of the bottom line of the rectangle here. So it's selected that midpoint of that line. Hold down Shift key and then click the origin point for the sketch. You'll see over on the left-hand side, we now have 2 points selected, and we're able to put in constraints for how those 2 points are arranged relative to one another. In this case, we're going to use the vertical constraint, which ensures that the center point, the midpoint here, will always be directly over the origin point. You can see that the left and right lines of the rectangle are now black, so they're constrained, which means we can't move side to side, but we can still move up and down. The last constraint that we need is we're going to make this line and this line collinear, i.e. they'll always be on top of one another. So again, you can click one line, hold down Shift key, and click the other line. You now have 2 lines selected, and then click the collinear constraint. As you can see, all of our lines are now black, and in the status bar down here, it says fully defined, so we're good to go. Go ahead and click Exit Sketch. We're now ready to bring our sketch into the third dimension. The most basic way to do that is to click on the Features tab in the toolbar, and then click Extruded Boss/Base. After doing that, click on your sketch, and you'll see it's now gotten this into mode where we're starting to bring this into a third dimension. It's automatically selected one of the rectangles here, but in order to select the other one, click on Selected Contours, and then select that shape as well. You now see that both of our rectangles are being brought into the third dimension, both being extruded, as it's called. But now we need to apply a thickness. We're making this out of sheet metal that is 1/8 of an inch thick, so enter 0.125. And then the last thing to do is where it says blind, click and switch to midplane. This means that the SolidWorks will equally extrude up and down so that our original sketch is in the middle of the part as opposed to being on one side. This becomes useful for aligning parts later, but at this point is pretty inconsequential. After you've done that, go ahead and click the OK check mark. And we now have a 3-dimensional piece of sheet metal from our sketch.